This video covers the Retest Review 15 over quadratic functions part 2. So 1 through 8 ask us to match the graph with the corresponding equations. So the first thing I'm going to do is see if there are any of these I can knock out. But my best advice for you is to plug these into y equals and see what your graphs look like. So for problem 1, we have an x squared. Now that one's kind of a basic, so I'm going to start with a different one because sometimes x squared is hard to see. So the second one is x squared plus 3. This is what my graph looks like. When I look at my graphs, I'm looking for one that goes up 3 from the vertex and then is a normal graph. H goes up 3 from the vertex and then is a normal graph. So problem 3, I'm going to put that exactly like I see it into y equals. So x minus 2 squared plus 1. I'm going to look at the graph and I can see this one shifted to the right and up from the vertex. So D shifts to the right and up from the vertex. 4 is a negative 3x squared, so negative 3x squared. I can see this one looks kind of skinny and is flipped down. It does not move anywhere on the from the vertex, so C would be my match there. Problem 5 is just a negative x squared. So this one I can see is fatter than C. Looks like B. Yep, B is the only one that's upside down and still at the origin. So notice the difference between C and B. When you put that big number in front of x squared, it gets skinnier. Problem 6, we have x plus 2 squared plus 1. When I look at the graph, I can see it's shifted to the left and up, so I'm looking for one that goes to the left and up. E does that. 7, I have a 1/2 x squared. When I look at my graph, I can see this one's kind of wider, looks very similar to F. 8, I have 2x squared minus 3. So I know it's going to go down and then get a little bit skinnier. A is the only one that goes down from the origin. So therefore, G has to be my parent function, which is the x squared. Sometimes that's easy to see, sometimes it's not, so that's why I saved it for the end. Now we're asked to find the domain and range of graph F. So always, domain and range, all reals all the time, always, all quadratic equations. My range for F starts at 0 and goes up, so my y's are getting greater than or equal to 0. Vertex and axis of symmetry for D. My vertex is the point 2, 1. So therefore, my axis of symmetry is x equals 2. (11) says if the graph of the quadratic parent function is stretched by 2, shifted up 2, and right 6, write the equation that could represent this. So to stretch, that's going to go in front. To go to the right needs parentheses, and whatever we put inside the parentheses is always the opposite of what we normally do. So right is normally a positive, so we put a negative. They did say quadratic, so I need to square it. And then it's going to go 2 up, so I'm going to add 2 to the end. If at any time you're not sure if what you wrote is what they wanted, then you can go back to y equals. Oh my gosh, sorry. You can go back to y equals, and you can do 2 times x minus 6. So I'm just plugging in what I put, and I'm going to see, does this stretch by 2? So does it get skinny? Did it move to the right 6? And did it go up 2? So yes, it did. So if at any point you're not sure, plug it in and see if what you wrote matches. The quadratic parent function is compressed by a factor of 1/4, reflected across x and shifted down 12. Write this transformation. So to reflect needs a negative in front. To compress needs a 1/4 in front. And then we're not going anywhere left or right, so I just put an x squared with no parentheses, and then to go down 12, we do a minus 12 at the end. 13 asks for us to describe these changes. So again, you can put it into y equals, or if you know your rules, inside the parentheses, as a positive is going to go left. If it's negative, it will go right. So it's going to go to the left 4. And then plus 6 on the outside or the back is going to move it up 6. My vertex would be a negative 4, 6. It's always the opposite of this and the same of this. 14 asks which function matches the graph below. So I'm going to see what my vertex is first. My vertex is negative 2, negative 3. So I need a function that says this as the opposite. So inside parentheses, I need a plus 2. And then this needs to be the same, which is true of D. If you're not sure, put all of these into y equals and see which one gives you this graph. If you can't tell between some of the differences, like if there's two that look kind of similar, use the table function on your calculator and find a specific point. 15 asks which matches this graph. So this one goes to the right too. I know that to the right needs a minus sign because it's always the opposite for the right. And I know that A is showing that it reflects, but this does not reflect, so C would be my correct answer. Again, if you're not sure if it's multiple choice, you can plug those answers into y equals and see which one matches the graph. Compared to the parent function, x squared is, so they're asking, so the negative is going to reflect. The 3 is going to stretch or make it skinny. And the minus 3 is going to shift it down. It will not go to the left or right because I do not have parentheses. 17 inside the parentheses is going to move it left or right. It's always the opposite of what we normally see, so a positive goes to the left. And then a positive on the outside does what it says, so that one's going to go up. 18, the negative in front is going to reflect. The minus 4 on the inside is going to shift to the right.